This video is on factoring perfect square trinomials. So this is a special factoring formula we're going to use when we have the case of a perfect square trinomial. And in case you're not sure what I mean when I say perfect square trinomial, think of if we had something of the form a squared plus 2ab plus b squared. And we want to figure out how we would factor that. To factor this, though, think about what this would be. If I had two sets of parentheses here, because you have a trinomial, you know you can kind of reverse FOIL that if it would work. To get a squared, we need a times a for our first part of FOIL. To get b squared at the end, we would need b times b to get the last part. And since it's a positive here, we know this would be a plus and a plus. So a times a would be a squared, and then it'd be plus ab, plus another ab would give us the 2ab, and then plus b squared. And so we could write this as a perfect square. Since it's a plus b times a plus b, it would be a plus b quantity squared. In a similar fashion, you could have the same terms except for with a negative for the second term. So if we had a squared minus 2ab plus b squared, this still would factor in the same way. Two sets of parentheses, a squared means we have a times a at the very beginning. B squared at the end, we would have b times b. Multiplying to a positive, you know the signs are the same because the middle has to be a negative. We know they have to add to a negative, so they're both negative. And you could check it. A times a is a squared. A times negative b is a minus ab. And this negative b times a would be another minus ab, so it gives you minus 2ab, and then a plus b squared from the end. And you could write this as a perfect square as a minus b squared, right? Same thing times itself, you just write it as that square. So when you have this, if you can identify one of these two forms at the very beginning, you might be able to jump right to what the factor would be as a perfect square at the end without having to write out all the factoring steps. Now, if you have to write the factoring steps, that's fine. This is just going to be a way that gives you a shortcut in case you would like to use it. It does help in some cases, really identifying if the first term is a perfect square and if the last term is a perfect square. You have the potential to be in one of these cases, meaning then you have to just check the middle to see if you get 2ab in the middle. Let's take a look at some examples. So if I said to factor, and I'll call this one a, I'll say I have 9x squared plus 42x plus 49. Now the first thing you should do when you're factoring, remember, is always look for greatest common factor. In this case, 9x squared, 42x, and 49, they do not have a GCF other than 1. So from there, you know, now I'm going to check to see if this is a perfect square trinomial. If you see three terms, typically what you do is you'd say, okay, I have three terms, I see a value in front of x squared, and then you might use an AC method on this or a trial and error. But if you notice that the first and last terms are perfect squares, if the middle comes out to 2ab, then this might fit into our format. So 9x squared, remember the whole thing has to be a perfect square here. So 9 is what number square? Well, it's 3. X squared is just x, so this is really 3x squared. So our a that I'm talking about here, right, is the 3x. And 49, is that a perfect square? Well, yeah, it is. It's 7 squared. So the b that I'd be talking about here is 7. So now what I'm doing here is I'm checking, right, this is a plus here, so we know that this is a positive still. I want to check, is this middle part 2ab? All right, we don't know. All right, we're going to find out. Is it 2ab? Let's still do plus in the end here. So is this 2ab? Well, 2 is just the value 2. All right, so it's a coefficient of 2. What's a? Well, a was 3x. And what's b? B was 7. So do these multiply to 42x? Well, let's just check it out quick. We're looking at this, and we've got 2 times 3x would be 6x times 7. So this does come out to 42x. So it checks out. So that's how you know that you have this form up here. Remember, we know it's plus because the middle term is plus, but that's how you know that you have a perfect square trinomial. It fits the format. The first and last terms are perfect squares, and the middle is equal to 2ab. We checked it equals 2ab, so we got it. So what's the format? Well, the format says this just factors to a perfect square of a plus b, the quantity squared. So we know that this will factor now to a, which was 3x, plus, because the middle term is plus, so plus, and then b, which was 7, and then the quantity squared. Now you could factor this traditionally as 3x plus 7 times 3x plus 7 and then FOIL it and see if you would get that back out, do a trial and error on it. But because the first and last terms are perfect squares, this gives us the potential to fall into one of these cases. If this didn't come out to 2ab in the middle, let's say you multiply these together and you got a different value and it wasn't matching up to 42x, then you couldn't use this formula. You would actually have to use a different formula. Let's take a look at another one. If I said we had 25y squared minus 90y plus 81. So first thing, look for a greatest common factor between all three terms. In this case, we don't have one. After that, you want to take a look and say, okay, I have three terms. You might want to use your normal, trial and error on this, but if we can notice the first and last terms are perfect squares, we might be able to fit our format. So 25y squared, is that a perfect square? Well, 25 is 5 squared, y squared is going to be y, that quantity squared. So we have 5y squared, so that's a perfect square. So this would be my a, if I was talking about it. And then 81, is that a perfect square? Well, yeah, that's 9 squared, right? So we know that this is a perfect square, and b would be 9. So now we're just checking. We want to check, does this middle, it's a minus, so that stay minus. So we know if we're using a formula from above, it'd be the second one, because there's a minus there. Is this 2ab? That's the question you have to ask yourself. Now I'm showing this here. You might be able to recognize it without writing it all out like I am, but I want to make sure you understand the thought process. Well, is this 2ab? Well, 2 is the coefficient, stays 2. A is 5y, and b is 9 times 9. So we want to see, does this multiply to the 90y? Well, we have 2 times 5y. That gives me 10y times 9. That does give me 90y. So this here comes out to 90y. It checks out, it matches up. That tells you have a perfect square trinomial. So right away you can write this as a, whatever that sign is in this case, is minus. So a is 5y minus b, which is 9, the quantity squared. Now if you were to FOIL this out, multiply it by itself, 5y minus 9 times 5y minus 9, you get back to here. And if you were to actually factor this in the methods that we learned previously for trinomials, you could get to the same answer. It might take you a little longer because you might be looking at a lot of different factors, but you could get there in the same way. So it's important to understand where that's coming from. If this again didn't multiply out to give you 90y in the center when you checked out the 2ab, then you wouldn't be able to use this formula. You'd have to factor it in traditional fashion for trinomials. Let's take a look at this one here. If I gave you might want to pause this for yourself as you're doing this, just so you can do the example on your own after I write it. But if I gave you 16x squared minus 88x plus 121. So you might want to try that out. So I pause it, try it out, and then come back and check the solution. So for 16x squared, well, first off, is there a greatest common factor? And in this case, no, we don't have one other than 1. All right, and then you could use your traditional factoring for trinomials, but you might want to take a look, see if this is a perfect square trinomial, recognizing if these are perfect squares. 16x squared, well, 16 is 4 squared, x squared is x squared. So this first part would be a 4x quantity squared, so my a would be the 4x. 121, is that a perfect square? Well, it is. It's 11 squared. So my b would be 11. Now all this tells me is I have the potential to have a perfect square trinomial if the first and last terms are perfect squares. It does not mean that it will be. So we have to check the middle. Well, the middle, remember, we want it to be 2ab. This one has a minus here, so it's minus 2ab, and this is what we're checking. Is this minus 2ab here? Well, 2 is the coefficient 2, a is 4x, b is 11. So I'm really checking to see 2 times 4x times 11. If you multiply that out, 2 times 4x is 8x times 11. Well, that's 88x And that's what I was checking to see if it was. Does it match the middle term? It does. The 88x is a minus there, so it checks out. Since this checks out, you know this has to be a. Since that's a minus, minus b, the quantity squared. Well, what's a? A is 4x minus what's b? 11. So it's 4x minus 11, the quantity squared. Let's take a look at just a couple more. If I was to look at this one here, so C is with D. If I was to look at 4a squared plus 52a plus 169. Now again, you might want to pause this for yourself and try it on your own. Taking a look here, is there a greatest common factor in this case other than 1? The answer here would be no. Right, so there's no GCF other than 1. I have 3 terms. I'm going to check to see if it's a perfect square trinomial. Remember, that can only happen if the first and last terms are perfect squares. So if I was looking at the 4a squared, is 4 a perfect square? Well, yes it is. It's 2. A is going to be a, and then that quantity squared, so 2a quantity squared. The 169, is that a perfect square? Well, it is. It's 13 squared. And if you're not sure, remember you can always use the square root button on your calculator to check if these are perfect squares. Now, if these aren't perfect squares, you can't use this formula. So now we have this here, and we're going to check. Now, remember when we talk about the formula, we're talking about a and b, but don't get confused with this a in here. Right, a from our formula was really just what I was talking about on the inside of this. B is what's really on the inside of this. We're checking to see, is this plus 2ab? So there's a plus sign, this is plus. Alright, 2ab, so 2 is the coefficient, so we have 2 times, well, what's a in this case? Don't get this confused with this a, it's really that part, so it's 2 times 2a times b, which is this part here, so times 13, so 2 times 2a is 4a times 13, that it does come out to 52a, so it checks out, it matches up. If it didn't match up, you wouldn't be able to use the formula. But since it does, and this is plus, we want the first term that was squared, so the 2a plus b, which was the 13, and then that quantity is squared. Again, you could use our other factor methods for trinomials. It's just a special case that helps give you a little bit of a shortcut. And we'll look at one more. If I said to factor 36y to the fourth minus 120y to the third power plus 100y squared. And again, you might want to pause the video for yourself here. Just try it out. Taking a look at this, is there a greatest common factor? Remember, that's your first question. In this case, yes, there is. Don't skip over that. Sometimes people do. In this case, there is a GCF. And the greatest common factor between 36, 120, and 100, they all have a common factor of 4. Y to the fourth, y to the third, and y squared all have a common factor of y squared. So 4y squared is our greatest common factor. We factor that to the front, remember. When you factor out a GCF, you're essentially dividing it out of each term, and then you're going to be writing what's left over in the parentheses after. Because remember, we're undoing the multiplication, right? When you factor, you're actually undoing multiplication, so you write it as a product. 36y to the fourth, factoring out 4y squared gives me a 9y squared. Minus 120y to the third, factoring out the 4y squared gives me minus 30y. Plus 100y squared, factoring out the 4y squared gives me plus 25. Now remember, when you're factoring, if you take out a greatest common factor, that greatest common factor, GCF, stays out in front for the entire problem. At the very end, you should still have the 4y squared in front when you're factoring. So 4y squared just drops down, and then I want to factor what's left in these parentheses. When I'm going into these parentheses, you want to count the number of terms. We have 3 terms. You know, typically if you're doing that, you'll say, do I see a value in front of the y squared? And then use either a trial and error or an AC method here. But because we know about our perfect square trinomials, if I recognize that these are perfect squares at the end, it's potential that I could factor this a little bit more quickly. 9y squared, if I was looking at that, well, that as a perfect square, yeah, 9 is 3 squared, y squared is just y squared, so that's like 3y quantity squared. 25, is that a perfect square? Well, yeah, that's 5 squared. And what you really want to do is, remember, we're checking the middle. Does the middle come out to a minus, in this case minus 2ab? Well, what's 2 times a? A is the 3y times b, which is the 5. So we end up with 2 times 3y would be 6y times 5. That comes out to 30y. It does match up, so that checks out. So then we go to write this as our factor. It's 4y squared times, and now remember, I'm taking whatever's in the parentheses here and I'm factoring this. So it's always a, which is the 3y, and then since this is a minus, it'll stay minus, and then whatever b is, which is 5, and then it's that quantity squared. And that's how this would factor down. So when you're looking at this, you know, the 4y squared stays in front of the GCF. When you're looking at this inside here, you handle the same way we just did earlier. It's a perfect square trinomial because, you know, you have a perfect squares at the end, and the middle is equal to 2ab. The minus sign keeps it minus in there, make sure it's the whole quantity squared. Don't try to square the 3y and the 5. Remember, that can't be brought back through this. If there's addition or subtraction here, the only way you can, you know, simplify this, really expand it in this case, if you multiply 3y minus 5 times itself. But then you'd be working backwards to here, right? You want to keep it in factored form and simplified form. So this gives you another factoring method. You know, it's a special case. You won't be able to use it every time. But if you recognize that you have a trinomial where the first and last terms are perfect squares, this is a potential way to factor it a little more quickly than just doing a trial and error and AC method. So hopefully that helps with this.